Hello and welcome to this video. In this video, we will try to understand Radix Sort and how it works. So we have the same main.c which we used earlier in our sorting algorithms. We have radix.h header file and we have radix sort.c. So this radix sort makes use of count sort function. Now this is different implementation than what we have done in counting sort example. This program will work only for positive numbers. This counting sort will not work for negative numbers. So it is used for simplicity so that we don't have extra code clustering up this space. Now this also makes use of a function which finds the max of an array. Now how Radix sort works is you find the max of the array and then you compare digit by digit. Okay, so in first case exponent starts with 1. Okay, and then as long as the greatest number divided by exponent is greater than 0, we increase the exponent by 10. So first we consider the unit numbers digit, then tens place, and then hundreds place, and then thousands place, and so on. We will see how this works because this is how the count sorts the count array which we have used in count sort. That's how we find the index. That's where exponent comes into picture. So you'll see if you try to execute that, if you follow my counting sort video, then you will have very clear understanding of what is going on here. If you are not to watch the counting sort video or you are not familiar with counting sort video, I request you to please watch the count sort video so that you can understand this whole routine. So basically, what is happening as I explained is first we'll compare the units positions digit, that is 9, 7, 0, 1, 3, 2, and so on. We sort on based on that. And then 6, 8, 0, 9, and so on. And finally, the hundreds place digit here. So that's how Radix sort works. So let's see this in action. I have already compiled this. Okay. You see the sorted array is our sorted array. So I'll repeat this for clarity. Again, we find the max of the array and then we run a for loop in which we have something called exponent and it starts with 1, and as long as that greatest number divided by exponent is greater than 0, exponent is multiplied with 10 because we are considering decimal digit. If we are treating binary numbers, this should be 2. For hexadecimal numbers, it should be 16, and for octals this should be 8. That is the base of the number system you are dealing with. And then you call count sort with 3, that is a and xp and exponent. Now note that one key factor, if it's a binary, this should be 2 and this should be 2. This should be 2. If it is hexadecimal, these should be 16, and in case of octal 8. So depending on your number system, this should be a different number. A better way would be to set the base here. Okay, and you set base into base is equal to 10 in this case, and then we put base here into base, and then we put base here. Base. So this should sort out our problem. So in case of octal, you just make it 8. In case of binary, make it 2. But for decimal, 10. So you see how the counting sort is working. It is actually acting on that particular digit. Okay, because we are taking modulo of base. So it operates on that particular digit of AI. So let's see this in action again. Let's see if base is 10. Base is 10. Let me compile this again and see if it works. Yeah, it's the same result. So Donald Knuth has given great treatment on Radix Exchange and Radix Sort here, Radix Exchange Sort. And this is how the iteration changes the numbers. So The algorithm is given here, and this is the mix implementation which you can read, and then it will be followed by the complexity calculation of Radix Sort. So I'll request you to read the discussion here to find out the complexity calculations of Radix Sort. I will not duplicate that material. And now I'll start making video on trees. I will introduce binary trees, binary search tree to begin with, and we will explore binary search trees, that in particular binary search tree, and then we will move on to graphs. And after we are done with graphs, I'll start presenting advanced data structures like red black trees and advanced sorting algorithms, AVL trees, 2-3 trees, and so on. And so we will see other algorithms like binary space partitioning, quad trees, oct trees, and so on. So I hope that you are enjoying this series of data structure videos. Most of data structure is fairly simple. The problems can be hard in data structure depending on the difficulty of the problem, but most of the data structures are pretty straightforward implementation. So if you find this video useful and informative, then please subscribe to the channel and like the video and share as much as you can, so that many more students like you can benefit from such programs. And if you have a comment or suggestion, or you want to say something, please make use of the comment box. Thanks a lot for watching. Happy programming.